Okay, this is Mr. Kinzer again. This is our last part 3 for lesson 28. And here's our hydrocarbon notes. Little review. Last week we learned about cracking petroleum and making through a process of fractional distillation. We put petroleum in a big tower, heat it up, and at different temperatures, different products are pulled off of the petroleum in this big fractional distillation facility. So we saw that natural gas comes off at about 104 degrees Fahrenheit, and gasoline comes off between 104 to 390 degrees, and then naphtha, and then diesel, kerosene, heating oil, lubricating oil, and finally we get a residue down in the bottom of this big container. It's real thick, gloppy, all the light, viscous, very thin, things like gas, like gasoline, very thin, evaporates rather quickly. Now we're left with all this gloppy stuff in the bottom, residue. And of course from that residue we said we can get paraffin, we can get different kinds of oils and asphalt. And so this is where we use. So the asphalt that they put out on the roads is really this residue from fractional distillation of petroleum. So petroleum is our main source of gasoline and naphtha and kerosene, all these different things. But we could also get them from coal. We also could get them from just about anything that has like natural gas. We can get some of these from natural gas. So it's really just the way we process is what we can get. Now we also have learned a lot about naming these molecules. So we said that these hydrocarbons, which are made of hydrogen and carbon, are in these chains, and the things that are really making this thing go, making this thing work, are the fact that carbon always has 4 bonding sites. So this is the special thing about carbon. It makes it very flexible. It has 4 bonding sites. So another thing is that it can have 3 kinds of bonds. So carbon can have a single bond, it can have a double bond, or it can have a triple bond attached to it. Now in this 6 carbon chain to the left here that you're looking at, and we, oh, by the way, we said that one bond on a carbon, if all of these are single bonds, then we would say this is what? A 6 carbon chain. That would be hex, would give us the prefix, the number of carbons, and then ane is the suffix that we use. So if it's just single bonds, this would be hexane, and we would put the rest of the hydrogens looking like this, realizing that for every one of these little sticks there's a hydrogen attached to it. We're not going to go all the way around and do this. That would be a huge waste of time right now. Now on a test you probably want to do that because I want to see that, but we could go all the way around adding that. So hexane is going to be C6. There's 6 of them. How many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're going to get C6H14. There's hexane. Okay. Now, if it has a double bond, it's going to be called ene. That's our suffix. And if it's got a triple bond, we're going to have yne, Y-N-E. And so, let's see if I can make that a little more clear for you. Let's see, Y-N-E, a little bit clearer. Okay, so let's name this molecule. See if you can do this one. This one's going to have a 5 carbon chain to it, and we'll put that. But one of the carbons has a double bond. So we said every carbon has four bonds around it. So there's 4 for that one. We're going to need 1 for this one. There's 4 for that one. We're going to need 2 for that, 2 for that, and 3 for this one. And we count. There's 1, 2, 3, 4. Remember, 1, 2, 3, 4. Remember, they're sharing a bond here. So these shared bonds are called what? What kind of bond? You have ionic, covalent, and metallic. So if you share, if you're sharing a bond, it are covalent bonds. And last week we said that if a carbon has the maximum number of hydrogens attached to it, then it is saturated. We call it a saturated hydrocarbon. So the question is this one right here, which is what? Ene. Is that pentene molecule saturated? Put a little question mark here. No, it's not, because it has a double bond. And that double bond means it's missing 2 hydrogens that it could have if it had a single bond. So saturated pentene would be have more hydrogens, and that's what saturated, and of course unsaturated means it doesn't have the number of bonds. And yes, this is a type of unsaturated bond. So let's go ahead and now make butene. Butene. Now, but is the prefix for how many? Yeah, 4. So you got to learn that chart. 1 is meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. So if we have butene, you would start out just by showing the 4 carbons because it's but. Then ine means it has at least 1 triple. So let's put a triple in there. You can really put it anywhere you want. Of course, you can't put it outside of the molecule, but anywhere between these carbons. And then you go through and you make sure that each carbon has their 4. Now, look at this one as we get to the middle. That has its 4. We don't need to add any hydrogens. This has 4. 1, 2, 3, and then 4. But this one, we've got to add 3 more hydrogens. So we've got 1, 2, 3, 4 bonds. So butane is going to be C4. 1, 2, 3, 4. Now how many H's? 1, 2, 3, 4, 5, 6. So C4H6 is butane. I think you guys can do this. This is not real tough. So we're going to review some more. And let's give you some notes, though, first. Now, these carbon chains can appear 4 different ways in a molecule, and it's the way the chains are arranged. The first way that they can appear is called an open chain. So there can be an open chain. So let's draw an open chain. An open chain would be your carbons, and really they look a little bit like this. There's a little bend in them. Looks like this when they actually bond. Now when you draw them, you don't have to show the little bend, but that's just how they really do look. This is a chain. Now an open chain would be if you have another carbon kind of stuck to the side, or another one over here. See? So that would be an open chain. Number 2, you might have this is an open chain with, let me take these last 2 off. Let me retreat a little bit here. Sorry about that. I'm going to take those last 2 carbons off. Oops, okay. Now right there, so you might have to erase something. I'm sorry, I got a little ahead of myself. This is the open chain. So you can see it has nothing attached. It's just the 5 carbons or 4 or 6 or 10 in a chain. That's an open chain. But we also have an open chain with links or crossovers. So I'm going to put open chain with crossovers. And that's really what I showed last time. I showed you an open chain with two crossovers. And sorry, I kind of got ahead of myself. But here would be a crossover, is adding a C there, or adding a C here. There's a crossover. Now, when you guys take organic chemistry in college, and you'll take that if you want to be a nurse or a doctor or a physical trainer, or if you're just interested, like I'd be interested just to be able to name these molecules. They will actually name molecules like this, and they will tell you there's a term for another chain that comes off the second carbon, and there's a term for the chain that has a second and a third carbon with a crossover. So they get real technical. Now, we don't do that in this class. We're just naming the chain because it has 5 carbons. So we would say both of these would be pentane. Pentane. They only have one bond between a single bond between the carbons, and they have 5 in the chain. So we have the open chain carbon structure. We've got the open chain with crossovers, carbon structure. Now let's look at a real cool one. It's called the ring structure. And we often call this a cyclic or a cyclic structure. Let's look at our ring, and it's kind of fun. You'll see this in chemistry. When you take chemistry, it's kind of fun to do a ring structure. And nothing real hard about it. This is a 5-carbon ring structure. And so whenever you see a ring, you would say the number of carbons comes first. So you'd say pent. There's 5 carbons. This would be pentane. It's only got single bonds. But you'd call it cyclopentane. That's because it's in a ring structure. Okay, now, what would you call it if it had a double bond here and a double bond there? Well, all you got to see is if it only has, all it needs is one double bond, and you change it from pentane to what? Pentane to what? Pentene, yeah. Okay, so it's cyclopentene. Let's put the hydrogens on it now. Remember, we need to have 4 bonds for each carbon. This little carbon is going to have 2. This is going to have 1. This is going to have 1. So we would say cyclopentene. Here is C5H what? 1, 2, 3, 4, 5, 6. C5H6. Okay, cyclopentene. So you now can name a ring structure. That's cool. Now the last type of structure that carbons have, carbon structures, the 4th type, is called chains with crossovers. Chains with crossovers. Okay, and so this is similar to that second one, which is a chain with crossover. Here's a chains with crossovers. So let's kind of show you what that looks like. All right, here we go. See. So you have one chain. That's a 5-carbon chain. And you have another chain. And look, we're going to show that they're linked. So these 2 chains are actually linked solidly together. So we have chains with crossovers. Now, what would you call this? I don't want you to worry about that, but because it's not a 10 carbon chain, it's not a 5 carbon chain, it's got a different name for it, but you should be familiar that they can look like this. You can get a hydrocarbon that looks like this. So when you start to think that these hydrocarbons can be 200 carbons long, and we try to create big long strands like nylon and polyester, for clothing, and we use this in some of the fibers for all kinds of material, for thread, for carpet. These are all big long carbon chains, and so we begin to see, wow, that's why there are 3.4 million different molecules of hydrocarbons. Isn't that amazing? Different molecules. And so let's talk a little bit about the next thing. I'd like you to name a couple of these molecules for me. So I'm going to write a molecule down, and I'd like you to name it. So let's try it. Let's give you a 7 carbon chain. Okay, and it's got a triple bond in here. Oh, stubborn. There we go. Got a triple bond. So we've got 3 hydrogens here, 2 here, none here. Look, we got our 4. Get all 4 of them. With this particular carbon. Then we got 4 with this carbon. This one can take 2. This one can take 2. Boy. So here are the carbons and the hydrogens. So we've got carbon. There's 7 of them. 1, 2, 3, 4, 5, 6, 7. It's hept something, right? Hept. And then we have how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. C7H11. And this has got a 3 bond, triple bond, heptine. Heptine. So it tells us we got a 3 bonded triple bond in there somewhere, and this has 7 carbon chains. So let me go ahead and give you a couple of these and let you work on them, and then we'll see how you do. Okay, so I hope that you've kind of marked your answers. Let's look at this first one and see how well you did. Number 1, it's a 4 carbon chain, so we know bute is the prefix, and it's got a triple bond in there. So this is going to be butine. Good. If you got butine, you got it right. Okay, number 2, we have a 5 carbon chain, but look, it's in a ring structure, so this is going to be cyclo, pent, what? Ene. It has a double bond in there, so we want to make sure that we state that. So all it needs is 1. It could have 3 or 4 double bonds. It could even look like this. It's still going to be cyclopentene. All it needs is 1 double bond, and it has the ENE, ending. Let's go to number 3. We have a 1, 2, 3, 4, 5, 6 carbon chain. That's going to be hex. And then we've got a triple bond and a double bond. Well, you always take the bigger one. So hexine. Hexine. I'm going to write it again so you can see it a little bit better. Hexine. I don't know that you can see that any better, but anyway, hexyne. And then number 4, let's look at that one. What was that? I should call on you guys, except I can't see you. 3 carbon chain, pro, and what? No, nothing but singles, propane. So this is the propane that we often use and burn in homes for heating. Now, one thing I'd like you to know is that for gasoline, you guys know you go to the gasoline pump and the gasoline is rated. And the way they rate it is they say it is 68 octane. Wow, there you know what an octane is, right? So they have, or they say if it's 72 octane, it's more expensive. It's got more octane. Now, octane is just the 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I think that's 8 right there. And so octane means it only has single bonds, and then it's got hydrogens all the way around. And this is the best length of gasoline molecule for burning in your engine. So the more octane, the more of these 8 carbon chain molecules that you have, the better. And so it's going to burn hotter, and you get more miles to the gallon with the higher octane. So here's an example where they actually use one of these terms, and the octane is really important in gasoline. So God bless you, and we'll talk to you next week.